Modern life often keeps us hunched over desks and steering wheels for hours at a time, a habit that inevitably leads to chronic physical stiffness. Our standard response is to fight that stiffness with force. We head to the gym and try to pull ourselves into deep, aggressive static stretches, pushing our joints as far as the pain will allow. This approach treats the human body like a mechanical assembly, assuming that muscles are simple rubber bands that just need to be stretched to grow longer. But pulling harder often creates the opposite effect, where the muscle actively resists the stretch and feels even tighter the following morning. Viewing muscle tension as a hardware problem ignores the reality that your muscles are under the constant, active control of your nervous system. Skeletal muscles are not dead weight. They are heavily wired with highly sensitive sensors that monitor every millimeter of movement. When you force a muscle to lengthen too quickly, your body interprets that sudden tension as a structural threat rather than a therapeutic exercise. Aggressive stretching doesn't lengthen the tissue, it triggers a high-speed biological panic button. To understand why this happens, we have to look past the surface at the microscopic environment inside the muscle tissue itself. These embedded sensors are called muscle spindles. Their primary job is to detect changes in muscle length and the speed at which those changes occur. If a muscle is pulled too fast, these spindles fire an immediate electrical warning signal to protect the joint. This signal travels at high velocity away from the muscle and enters the spinal column, bypassing the slow, conscious parts of your brain. This is the myotatic reflex. It's the same loop causing your leg to kick involuntarily when a doctor taps the tendon below your kneecap. This reflex evolved as a survival mechanism, designed to keep us standing upright and to prevent muscles from tearing under sudden loads. As soon as the spine receives that warning from the spindles, it launches an immediate countermeasure. A new signal, the alpha motor neuron signal, is fired back down to the target muscle. This is a subconscious command that forces the muscle to actively contract against the stretch to maintain its integrity. This creates a direct physiological conflict. Your conscious mind is trying to relax, while your spine is simultaneously demanding that the muscle tighten up. Because the neurons carrying these reflex messages are heavily myelinated, they travel much faster than conscious thought. Forceful stretching leads to a literal tug-of-war against your own protective nervous system, a war you will inevitably lose. To improve mobility, we have to stop trying to muscle our way through a fight, and instead start communicating with these neurological pathways. One method relies on time and subtlety. By holding a very gentle stretch for 30 to 60 seconds, you allow the muscle spindles to adapt to the new length, eventually diminishing their defensive response. Another strategy is PNF stretching, or proprioceptive neuromuscular facilitation. By briefly contracting the muscle against resistance, you engage the Golgi tendon organs. This triggers a response called post-isometric relaxation, which resets the baseline level of tension that your nervous system is trying to maintain. These techniques improve range of motion by speaking the nervous system's language and temporarily lowering its protective neurological safeguards. This leads us to the final technique, pandiculation. These slow, active, and highly controlled movements teach the nervous system that it is safe to operate at the extreme ends of its range of motion, rather than triggering a reflex panic. True flexibility happens when the nervous system realizes it is finally safe to let go.